Hello kids, welcome to today's maths class, and today we'll do playing with numbers. Introduction. In the previous class, we have studied the basic idea about the factors and multiples. In this chapter, we shall review these ideas and extend our study to include some new properties. Here by numbers, we would mean only by counting numbers. Next is factors and multiples. The number which divides the given number exactly is called the factor of the given number, and the given number is called the multiples of its factor. Means if a number divides the other number exactly, means remainder should be 0. That means that number is the factor of given number, and that number जो हमें मिलेगा that is the multiple of that number. For example, as we know that 21 equals to 1 into 21. And 21 equals to 3 into 7. Clear? 21 equals to 1 into 21 भी होता है, and 21 equals to 3 into 7. So this shows that each of the number 1, 3, 7 and 21 that exactly divides the number 21. Therefore 1, 3, 7 and 21, they are the factor of 21. In the other word, we can say that 21 is the multiple of 1, 3, 7 and 21. Thus we conclude that if the number x divides the number y exactly, then x is called the factor of y and y is called the multiple of x. Clearly 1 is the factor of every number. 1 जितने भी number है उसका factor होता है, and every number is the factor of itself. It may be noted that 1 is the only number which has exactly one factor, namely itself. Next is properties of factors and multiples. Every factor of a number is an exact divisor of that number. Means जो भी factor होगा वो number को exactly divide करेगा. 1 is the factor of every number. Every number is the factor as well as the multiple of itself. जितने भी number है खुद का भी factor होगा. Means if we talk about the factors, जो मैक्सिमम फैक्टर होगा, ये सबसे बड़ा फैक्टर होगा, दैट इज द नंबर इटसेल्फ, एंड जो सबसे छोटा मल्टीपल होगा दैट इज द नंबर इटसेल्फ. क्लियर? एवरी फैक्टर ऑफ अ नंबर इज लेस देन और इक्वल टू द नंबर, while every multiple of the number is greater than or equal to the number. The factors are finite. Factors क्या होते हैं? Limited होते हैं, finite, but the multiples are infinite in the number of the given number. If the sum of all factors of the number is equal to the twice of the number, then the number is called the perfect number. Clear? Perfect number क्या होगा? The sum of all factors of the number equals to the twice of number. Means जो sum है factors का, that should be twice of that number. That means that number is a perfect number. Clear? Next is exercise 3.1. Write down all the factors of first is number 25. Factor of number 25, that is 1, 5 and 25. So these are the factors of given number. Clear? So you have to practice all the questions of this exercise. Next is various type of numbers. First one is perfect number. So what is a perfect number? A number is called perfect number if the sum of all its factor is equal to the twice of number. For example, the factor of 28 are 1, 2, 4, 7, 14 and 28. Sum करेंगे. What is the sum of these numbers? That is equals to 56. That is the twice of number. Means 2 into 28, that is equals to 56. Means 28 is a perfect number. The sum of the factor 28 is the twice the 28. So 20 is a perfect number. Next is prime numbers. A number which has only two factors, 1 and the number itself, is called a prime number. They are infinite number. Next is even number. All multiples of 2 are called even number. It follows that any number divisible by 2 is an even number. If a given number is exactly divisible by 2, that means that given number is an even number. Hence 2, 4, 6, 8, 10, 12, etc. all these are even number. Next is odd numbers. Number which are not multiple of 2 are called odd numbers. For example, 1, 3, 5, 7, 9, 11, 13, they are not exactly divisible by 2, so these are odd numbers. Next, note to remember. All prime number except 2, 2 को छोड़ के जितने भी prime number है, they all are odd numbers. But it is not necessary that every odd number is a prime number. But ये ज़रूरी नहीं कि जितने भी odd number है वो prime number ही हो. For example, 25 is an odd number, but it is not prime number. Next is composite number. Composite number, the number which have more than 2 factors are called composite number. They are infinite in numbers. For example, 4, 6, 8, 9, 10, 12, all these are composite number. Next, note to remember. 1 is neither a prime nor a composite number. 1 ना तो prime number है ना ही composite number, because it has only one factor, that is 1, that is number itself. Whereas prime number have 2 factors and composite number have more than 2 factors. So it does not satisfy the definition of anyone. ना तो ये prime number की definition को satisfy करता है ना ही composite number की. 2 is the lowest prime number and only even prime number. Next is twin primes. 2 consecutive odd prime numbers are known as twin prime numbers. For example, 3 and 5, whose difference is 2. 11, 13, difference is 2. So all these are twin prime numbers. Prime triplets. A set of 3 consecutive prime numbers differ by 2 is called prime triplets. Like 3, 5 and 7. The difference between these numbers are 2. 3 और 5 में 2 का difference है, 5 and 7. The difference is 2. So these are the prime triplets. Only one prime triplet. Next is co-prime. 2 numbers are said to be co-prime if they do not have a common factor other than 1. It is not necessary that the co-prime numbers are prime itself. 2 prime numbers are always co-prime. For example, 3 and 4, 4 and 9, 5 and 13, all these numbers are co-prime number because they do not have any common factor other than 1. Next is finding of prime numbers. Without actually checking the factors of the numbers, we can find the prime numbers from 1 to 100 with an easier method. The method was found by the Greek mathematician Aristophanes. So it is called the sieve of Aristophanes. This is the sieve of Aristophanes. What is the procedure of finding prime numbers? Step 1. First, we'll cross 1 because it is neither prime nor composite. Then encircle 2 and cross out all the multiples of 2 like 4, 6, 8, 10 and so on. Then circle 3 and cross all the remaining multiples of 3 like 6, 9, 12, 15 and so on. Then encircle 5 and cross all the remaining multiples of 5 like 5, 10, 15, 20 and so on. Next, encircle 7 and cross out all the remaining multiples of 7 like 7, 14, 21 जितने भी multiple है उसको cross कर लेंगे. Now encircle each one of the remaining number. All the encircle number, they are prime number and remaining numbers are composite number. So prime number less than hundreds are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. These are the prime number between 1 and 100. Next is exercise 3.2. State whether the following statements are true or false. 2 is the smallest even prime number. Yes, 2 is the smallest even prime number, that is true. So write T for it. Clear? Next is divisibility test of numbers. How will we check whether the given number is divisible by another number? For that we will use divisibility test. without doing actual division to find whether the given number is divisible by any other or not. It is called divisibility test. First is divisibility by 2. A number is divisible by 2 if its unit place digit is even, means if it is 2, 4, 6, 8 or 0, that means that number is divisible by 2. Like here, all the number they have 4, 8, 6, 4 at unit place. So all these numbers are divisible by 2. Next is divisibility by 3. A number is divisible by 3 if the sum of its digit is divisible by 3. For example, consider the number 7692. Sum of digits 7 plus 6 plus 9 plus 2, that is 24, and 24 is divisible by 3. So the given number is divisible by 3. Next is divisibility by 4. A number is divisible by 4 if the number formed by its tens place and the unit place digit is divisible by 4. For example, consider the number 762. So digit at unit place and tens place, that is 62. Now we'll check if 62 is divisible by 4 or not. No, 62 is not divisible by 4. So this number is not divisible by 4. Clear? Next is divisibility by 5. A number is divisible by 5 if its unit place digit is 0 or 5. For example, all these numbers, they have 0 and 5 at unit place. So these are divisible by 5. Next is divisibility by 6. A number is divisible by 6 if it is divisible by both 2 and 3. If a given number is divisible by both 2 and 3, that means it is divisible by 6 also. For example, 2112. This number is divisible by 2 because unit place पे 2 है. Sum of digit 2 plus 1 3 plus 1 4 and 2 6. That means it is divisible by 3 also. So this number is divisible by 6 also. Clear? Next is divisibility by 8. A number is divisible by 8 if the number formed by its digit at the 100, tens and unit place is divisible by 8. Means from right hand side, last 3 digits are divisible by 8. That means the given number is divisible by 8. Here, last 3 digits 992. That is divisible by 8. So the given number is divisible by 8. Next is divisibility by 9. A number is divisible by 9 if the sum of digit is divisible by 9. For example, all these numbers, the sum of the number जो digits है, sum of the digit that is divisible by 9. That means the given number is divisible by 9. Next is divisibility by 10. A number is divisible by 10 if its unit place digit is 0. For example, here in given numbers, the unit digit is 0. That means these numbers are divisible by 10. Next is divisibility by 11. A number is divisible by 11 if the difference of the sum of its digit at odd place and the sum of digit at even place is either 0 or the multiple of 11. Consider a number like here. This is the number sum of digit at odd place, that is 6, 8 and 9. Sum is 23. Sum of digit at even place, that is 1 plus 0, that is 1, and their difference is 22. That is the multiple of 11. That means the given number is divisible by 11. Clear? Next is exercise 3.3. Which of the following number is divisible by 2? Means multiple of 2. So here the first number 362. Unit place digits 2. That means this number is divisible by 2. Next, this number is not divisible by 2. It is divisible by 2. This number and this. These are the number which are divisible by 2. So you have to practice all the questions of this exercise. Next is common factor and common multiples. Now we'll take an example. Find the common factor of 9 and 24. For that, first we'll find the factors of 9. They are 1, 3 and 9. Factors of 24, they are 1, 2, 3, 4, 6, 8, 12 and 24. What are the common factor? That are 1 and 3. So common factors are 1 and 3. Clear? Next is prime factorization. A factorization in which every factor is prime is called prime factorization of the number. For example, 48 can be written as 2 into 2 into 2 into 2 into 3, means the product of prime number. So representing a number in the form of product of prime number, that is called prime factorization. Here all the factors of 48 and 125 are prime numbers, so they are called prime factorization. This process representing a number in the form of product of prime number is called prime factorization. Next, note to remember. Prime factorization is the type of factorization where the number is expressed as the product of prime factors. One and composite numbers are never used in prime factorization, only we use prime numbers. Next is tree method to find prime factors. Working steps are: split up the given number into two factors in such a way that one factor may be prime and other factor may be composite. Now once again, split up the composite factors into the two factors in such a way that one may be prime and other factors may be composite. Continue this process until all composite factors change into prime factors. For example, consider two numbers 120 and 980. If we see the prime factorization of 120 by factor tree method, first we will divide 120 by the smallest prime number it can be divided, that is 2. Here 2 is the prime number, 60 is composite number. So again we will divide by 2, we will get 30. 30 is composite number. Again we will divide by 2, we will get 15. Now we will divide by 3, so we will get 5. Here 3 and 5 are prime numbers. So prime factorization of 120, that is equals to 2 into 2 into 2 into 3 into 5. Clear? Next is exercise 3.4. Find the common factors of 35 and 50. So first we will write the factors of 35, that is 1, 5, 7 and 35. Next, factors of 50, that is 1, 2, 5, 10, 25 and 50. Now common factor, that are 1 and 5. So common factors are 1 and 5. Clear? So practice all the questions of this exercise. Next is highest common factor, HCF. The greatest number which is common factor of two or more numbers is called the highest common factor, HCF. It is also known as greatest common divisor, written as GCD, means greatest common divisor. There are three methods to find HCF. One is common factor method, second is prime factorization method, and third is continued long division method. Next is note to remember. If one out of the two given number is the factor of the other, then the smaller number is required HCF of the given number. For example, HCF of 7 and 14 is 7. Since 7 is the factor of 14 and 7 is the HCF of 7 and 14. Next is common factor method. So in this method, first find the factors of given number, then find the highest common factor. This is required HCF of given number. For example, find the HCF of 30 and 42 by common factor method. So first we'll find out the factors of 30 and 42. These are the factors of 30 and 42. Now what are the common factor? That is 1, 2, 3, 6. These are the common factor. Clear? Out of this, 6 is the highest common factor. So HCF of 30 and 42 is 6. Clear? Next method is prime factorization method. First find out the prime factors for given number, then find the product of all common prime factor. This is the required HCF of given number. Like here, first we'll do the prime factorization of the given number. So here the prime factorization of 170 and this is 238. So 170, 2 into 5 into 17, 238, 2 into 7 into 17. So HCF क्या हो जाएगा? Common factor, that is 2 and 17. So HCF, that is 34. Next is continued long division method. In this method, we divide the larger number by smaller number. Obtained remainder is considered to be new divisor and first divisor will be new dividend. Clear? Now obtained remainder is considered as a new divisor and the second divisor is a new dividend. Continue this process until the remainder becomes 0. The last divisor is the required HCF of the given number. For example, find the HCF for 84 and 144 by long division method. So in this process, first we will divide the greater number with smaller number. So 144 divided by 84. One time divide होगा, 84 subtract करेंगे, we will get 60. Now 60 will become the new divisor and 84 will become the new dividend. One time again 60 subtract करेंगे 24. 24 will become the new divisor and this divisor will become the new dividend. Keep dividing until we get 0. So last divisor is 12. So that is the HCF of given number. Clear? So this way we can find out the HCF of given number by the long division method. Next is exercise 3.5. Find the HCF of the following by the common factor method. So number are 18 and 48. First we'll find out factors of 18. 1, 2, 3, 9 and 18. 48, 4, 'These are the factors of given number. Now we have to find the common factor. Common factors are 1, 2, 3, 6. Out of that, 6 is the highest. So HCF is 6. Clear? So practice all the questions of this exercise. Next is lowest common multiple or LCM. The lowest common multiple or LCM of two or more given numbers is the smallest or the lowest or least of their common multiples, which is exactly divisible by each of the given number. There are three methods to find LCM. First is common multiple method, other is prime factorization method, and third is common division method. Note to remember. The meaning of lowest common multiple. Lowest means least, common means something which is shared on in common, means दोनों share कर रहे हैं जिसको. Multiple, what we get when we multiply. First is common multiply method. In this method, first find out the multiple of each given number. Write the common multiples of each given number. Out of these multiple, take the smallest multiple. The smallest multiple is required LCM. For example, find the LCM of 5, 10 and 12. So first we write out the multiples of 5, 10 and 12. As we know, multiples are infinite. So 5, these are the multiple of 5 and these are the multiple of 10. and these are the multiple of 12. Clear? Now common multiples find out करेंगे, that are 5, 10, 12, 60, 120 and so on. But which one is the least? means सबसे छोटा कौन सा है? That is number 5. So 5 is the LCM of 10, 12 and 60. Clear? Next is prime factorization method. Find the prime factorization of each given number. Find the product of all different prime factors using each common prime factors. The greatest number of time it appear in the prime factorization of any of number, thus the obtained product or LCM of given number. For example, find the LCM of 63, 108 and 136. So first we will do the prime factorization of these given number. Now what will do? जिसकी भी लाइक यहाँ पे नंबर कौन कौन से है? 2, 3, 7 and 17. So what will do? We'll write their highest power. Like 2 maximum कितने टाइम आया है? Maximum है 3 times. So we'll write it 3 times. 3 maximum कितने टाइम आया? 3 times. So 3 times. Then 7 1 time and 17 1 time. So multiply them, 25,704. That is the LCM of given number. Clear? Next is common division method. In this method, arrange all the given number in the line or any order. Use comma to separate. Divide by the prime numbers which divide exactly at least 2 of the given number. Write down the quotient of the divisible number and carry undivisible number as if it in next line. Repeat the process until we get the line number as 1, 1, 1, 1, etc. Now the product of all divisor is required LCM of given number. Suppose we have to find out the LCM of given number. So what will do? इस तरीके से हम करेंगे, प्राइम नंबर से डिवाइड करेंगे. फर्स्ट एटलीस्ट 2 नंबर शुड बी डिविजिबल. So 2 से डिवाइड करेंगे. 35 is not divisible by 2. So we'll write it as it is. 105 as it is. 70 and 90. Again 2 से डिवाइड होगा. 35 as it is. 105 as it is. 35 हो जाएगा. 70 divided by 2. 90 divided by 2. 45. Now this number is not divisible by 2 anymore. So divide by 5, 7, 21, 7 and 9. Now we'll divide the number by 7, 1, 3, 1 and 9. Now divide by number by 3. So we'll get 1, 1, 1 and 3. Again 3. So 9 will get 1, 1, 1. So LCM equals to 2 into 2 into 5 into 7 into 3 into 3. 2 into 2 into 5 into 7 into 3 into 3. That is 1260. Next is exercise 3.6. Find the LCM of the following number by common multiple method. So first we'll write the multiples of 3. That is 3, 6, 9, 12, 15, 18, and so on. Multiple of 5, 5, 10, 15, and so on. And so on. अगर 3 की मल्टीपल्स हम आगे लिखें तो विल रीच 60. 5 में भी हम 60 पहुंच जाएंगे. सो द लीस्ट कॉमन मल्टीपल दैट इज 60. फर्स्ट विल फाइंड आउट कॉमन मल्टीपल. लीस्ट कॉमन इज 60. सो एलसीएम ऑफ 3, 5 and 12 is 60. Clear? Next is some practical application of HCF and LCM. We'll take an example. 3 pieces of cloth, 18 meter 25 centimeter, 15 meter 75 centimeter, 12 meter 50 centimeter long have to be measured. Find the length of the longest tape which can measure 3 clothes exactly. Clear? Require the longest tape means we have to find the HCF of 18 meter 25 centimeter, 15 meter 75 centimeter and 12 meter 50 centimeter. So first we'll convert them into centimeter. 1825 centimeter, 1575 and 1250 centimeter. Now we'll find the HCF by long division method. So last divisor, here what we have done, first we have taken two numbers like this. We'll divide 1575 by 1250. Here we get 0, last divisor is 25. Now we'll divide 1825 by 25. So last divisor is 25. So the length of the longest tape, that would be 25 centimeter. That is the HCF of given number. Clear? So practice all the examples here. Clear? Next is exercise 3.7. Find the least number which is divisible by 24, 16 and 12 and leave a remainder 5 in each case. So what we'll do? We have to find the least number, means LCM of 24, 16 and 12. LCM find out करेंगे. अगेन 2 से डिवाइड हो सकता है, अगेन 2 से, now it will divisible by 3 only. So LCM हो जाएगा 2 into 2 into 2 into 2 into 3, that is 48. Now in each case remainder is 5, so we'll add 5 to it. So answer is 53. So practice all the questions of this exercise. Next is properties of HCF and LCM. The HCF of the given number is smaller than that or equal or smallest number. The HCF of two co-prime number is 1. The LCM of given number is greater than that or equal to the largest number. The LCM of two co-prime number is equal to their product. The HCF of given number is always a factor of their LCM. If x and y are two given number such that x is a factor of y, then HCF is equal to x and LCM is equal to y. For example, consider the two number 20 and 60. 20 is the factor of 60. So HCF for 20 and 60 is 20 and LCM of 20 and 60 is 60. Means जो greater number है वो LCM हो जाएगा, जो smaller number है that is HCF, which proves the property. The product of two number is equal to the product of their HCF and LCM. Note to remember. One number multiply other number equals to HCF multiplied by LCM. If we have to find the one number, so what we'll do? LCM or HCF के product will divide the other number. So to find the HCF, what we'll do? Product of the given number divided by LCM. Clear? To find the other number, product of HCF and LCM divided by one number. To find the LCM, product of the given numbers divided by HCF. Clear? That is the formula. Next is exercise 3.8. Complete the following table. Here, the first number is 16, second number is 28. So we have to find out HCF. लॉन्ग डिवीजन मेथड का यूज कर रहे हैं. सो HCF हो जाएगा 4. Are they prime numbers? Are they prime? Means 16 and 20 they are prime numbers? No, they are not prime number because they have more than 2 factors. LCM find out करना है 16 and 28. Again divide by 2. सेवन एज इट इज आ जाएगा 1 and 7 7. सो एलसीएम हो जाएगा 2 to the 4 4 to the 8 8 to the 16 16 into 7. $112. A into B means 16 into 28 and HCF into LCM. तो आप इन दोनों को मल्टीप्लाई कर लेंगे like this. Clear? So practice all the questions here. Next is things to remember.
Action.
Next is things to remember. A factor of a number is an exact divisor of that number, and the number has finite number of factors. A multiple of a number is exactly divisible by the number, and the number can have finite number of multiples. Every number is the factor and multiple of itself. 1 is the factor of every number. 2 is the smallest and only even prime number. 2 consecutive odd prime numbers are known as twin prime numbers. 2 numbers are said to be co-prime number if they don't have a common factor other than 1. Number 1 is neither prime nor composite. The LCM of the any 2 prime and co-prime numbers is equal to their product. Next is multiple choice questions. Take the correct option. In the factors of a product are 9 and 19. The product is, in the factors of a product are 9 and 19. So number C is the correct option. Clear? So here we end the chapter. I hope you understand it well. Now you to practice it.